We are joined now by Shane Curran. You may know Shane from some of the BT Young Scientist promotional videos as the winner of the 2017 Young Scientist exhibition. Shane, how are you doing?
I'm all good. How are you, Jack?
Good, doing well. So obviously, I suppose you yourself, first and foremost, would be one of the most prominent examples of a young scientist success story on a massive scale, given the fact that from, I suppose, humbler beginnings back in 2017, from winning the Young Scientist, you've come on leaps and bounds with your idea. Now, the idea has turned into a bit more than a Young Scientist project and has evolved into EverVault. So I suppose for some of the students who may not fully know what EverVault is, can you give us a quick run through as to what that entails?
So we're a company. We're about 18 months old. We build tools for software developers that let them build secure apps and services. So anything from a consumer banking app to government software. We make it easy for them to keep information secret through encryption and other kind of ways of keeping data safe that I would have researched a few years ago at the BT Young Scientist.
Okay, so small scale stuff.
Yeah, exactly. Nothing too major.
You touched on the point of data privacy there, and I suppose 2020 has seen, first of all, a massive increase on the amount of people online. We're all doing interviews on Zoom, or we're all partaking in an online sphere. Given the uptake of online participation, how does that play out in the important sort of role of data privacy in your mind?
I think obviously it's very important, and I think people always point to the obvious trend of more people going on the internet and things like that. But the reality is it's a trend that's been going on for 20 plus years at this stage. It's just the past year has really kind of been a forcing function to make sure that it happens a lot quicker than it normally would have. So there's kind of the obvious examples of people using more online services, more consumer data going on the internet. But although some people would argue that internet growth has kind of stagnated slightly and it's kind of not growing at the same rate it was maybe 10 or 15 years ago. The reality is, it's the absolute number of people that are using the internet is just crazy around the world. I think there's last year there's 3.5 billion people. Probably by the end of the decade, it's something like 4.5 or 5 billion people, with everything from Starlink, Elon Musk Starlink, to just kind of better regional internet connections. But I think there's just more and more products coming onto the internet. Even things that don't necessarily need to be on the internet are now coming online. Other kind of major tech companies like Apple and Google and so on have kind of indicated that the future for those companies, specifically Apple, is in healthcare. And it's kind of the first time that healthcare has really kind of started to come on the internet. Although kind of hospitals and doctors' surgeries and so on have been using computers for quite a while. The reality is most of them are kind of air-gapped and siloed away from the rest of the internet. But now that there's these kind of centralized technology platforms to keep track of patients and medical records and so on, there's just more and more there's more and more data coming online. But the more important thing is that the sort of sensitivity of the data is growing a whole lot more. And because it's happening so quickly, it's just extremely difficult for the software developers and kind of company builders who are creating these new products to consider that from day one, just because they're in such a rush to build their products. They themselves are trying to find product market fit and find customers for their business and so on. So it's just a really hard thing to kind of get people to think about. And for us, it's just really important we build the tools to let them integrate those services and those technologies from day one without them having to worry about it later on.
Okay, very good. It's so I suppose I want to rewind there back to the Young Scientist days for a quick moment. Now, obviously, you found the biggest success in 2017, but you've entered quite a number of times. How many times have you entered, Shane?
I've entered 4 times. So yeah, definitely kind of used to the competition itself and the application process. I think I still remember a lot of the questions to this day. So it wasn't a new experience the last time I did it.
Fair. And I suppose you touched on the point there of, I suppose, being at your stand, getting all those questions from a wider range of, I suppose, teachers, students, judges, and every sort of guest visitor that comes in through those doors. But what would be some of the most standout things that you've learned from your time competing at Young Scientist?
I think overall, the thing that you really realize is how important kind of the age of people doing the Young Scientist. I think it's everything from kind of 12 to 18 or thereabouts. I think it's just they're probably the most formative years for people to kind of figure out what they want to do, after they leave school, or whether they go to college or so on. I think for most people that's kind of generally the path that they tend to follow. And I think people tend to underestimate teenagers in terms of what they can do. But the reality is, like, with the right guidance and with the right, I think with the right ambition as well, I think people, particularly students, maybe it's just sort of part of being a teenager and hormones and all those sorts of things. But sometimes people when they're younger can find it difficult to back themselves to kind of take on a more meaty problem. And I think the students who take on projects like that, and the ones who back themselves to kind of solve something major, are, on average at least, I think the ones that reap the rewards. And I think that's like totally it's the exact same thing in sort of post college life, or kind of at least in the business world anyway. It's the big problems that are the most valuable to the people that end up kind of solving them and creating products and projects to kind of work around them. And it's the same in academia as well. So I think kind of just realizing how capable young people actually are, and kind of giving them the space to do that where they normally wouldn't, and especially with judges of the caliber that the Young Scientist has, and it's taken seriously, and I think that's completely the right thing. So I think even for us as a company, when it comes to hiring, we people who would be sort of traditionally undervalued, maybe who don't have the experience or whatever, like the reality is they're sometimes the most capable because they haven't learned the bad habits. They're the most ambitious and most hungry. So I think it's just realizing how capable young people actually are. And kind of the contrast between how capable they are and how capable they think they are is pretty vast.
So you touched on the point there about, when you're hiring people for Revolt, that you kind of touch on the, I suppose, the critical thinking side of things, or the adaptability. Do you think competitions like the Young Scientists help that with students? And in, I suppose, what sort of ways would the Young Scientists help students prepare for the real world after school is over and done with?
Yeah, for sure. I think like the most shocking thing even out of the whole thing is just how quickly it happens. At least back when it was in the UAS, and I think it's similar this year as well when it's online. But from the Wednesday to the Friday or Saturday, like the change that happens, at least I can speak to my own experience on it. But even just seeing other students around, like how quickly you just kind of iterate on your pitch and presentation, you just get extremely good at kind of figuring out who you're actually pitching this to, or presenting the idea to. And you end up having kind of 3 or 4 different simultaneous explanations to different types of people and what they might actually be interested in. And I think that parallel can be drawn in kind of everything. I mean, even in software, for example, there's all these kind of ideas around minimum viable products and iterating and things like that. Like, I've never personally been a fan of those things, but the reality is, even if you're writing an essay or whatever, you always have to kind of take a first draft of something and then just keep on kind of iterating on it and kind of improving it before you ship it to customers or ship it to people who are reading it, or whatever the thing itself is. And I think doing that in a really condensed period of time is kind of the easiest way to make that happen, because while you could kind of do it passively for a couple of years and you might make any kind of great progress on it, just being forced to be in the same room or in the same Microsoft Teams meeting, and as is the case this year, kind of presenting the project, it just forces you to be really good at kind of improving your presentation, which is kind of like the standout point. And the standout point there, I think, is just focus. If you don't have distractions, and if you're willing to kind of just focus on one particular thing, which is, at least during the exhibition itself, kind of improving your presentation and how you convey your project to other people, it will improve. There's really no difference between the kind of during school Young Scientist exhibition and stuff like that, and then kind of the non-school world where you're in business or whatever. It's really the exact same. People are motivated by the same things, the same fears, the same ambitions. They just get better at masking it.
Fair enough. It's a really good point that you made there. I suppose obviously you're in touch with quite a number of alumni from past competitions or from organising it down along the years. So I suppose, in your own words, Shane, what does a Young Scientist community look like to you, or what's that like for you?
I think I don't know if it's a Picasso quote or something like that, but it's something like when great painters meet in a room, they don't talk about paintings, they talk about where to buy cheap turpentine. And I think that's totally true. It's the exact same thing with a community like the Young Scientist alumni or similar kind of groups. It's just being able to be friends with people, and you just sort of have that underlying thing in common where you can kind of have basic conversations about it the odd time, but the reality is you're still just kind of young people who have similar backgrounds who are interested in the same things. So it's nice to just hang out without having to kind of make the good impression or anything like happens quite frequently in the real world, I think.
Now, obviously, this year would be quite different to other years insofar as everything is being done virtually, as is everything else in the world right now. What advice would you give to students, I suppose, to make the most of the experience, to make the most of the week, whether it's networking or attending events or learning a bit more about their own ideas and kind of fueling their own ambitions, as you mentioned earlier?
The thing that I enjoy the most about young scientists is kind of the one-on-one conversations. And I think they're, if anything, the easiest things to replicate in an online setting. Like, big events and stuff like that are obviously not the same, but being able to have conversations with people just one-on-one, which, I think the current platform completely allows, I think is the big thing. And although it might feel extremely uncomfortable, and, thinking back, it would have been extremely uncomfortable for me as well, but just to kind of message someone and say, your project looks interesting. Do you want to, I don't know what the verb is, like hop on a Zoom or whatever you say these days. Small groups, I think, are the most valuable part of the whole thing, because although the events are interesting and things like that, I think you always just naturally get the most out of conversation if it's kind of just a bilateral thing and you're asking each other questions.
Moving on from that point, there would be quite a number of students, I can imagine, whose ideas could very well be the next Evervault or the next Venue Health or the next young scientist success story. Taking Evervault as a clear example, what, I suppose, key points would you give as terms of advice for students looking to turn a young scientist idea into a bit more of a business exploration?
It's very easy for people to kind of just look at the business world and assume that there's all these kind of crazy complexities and stuff that exist there that don't exist in kind of doing pure science research. But the reality is I kind of distill it down to one single thing. And although there's like two types of companies, you've got companies who are kind of trying to build a product that they think people might like. And, it's this kind of weird mixture of finding a market and building a product for it. As well as the other camp of companies, which are, equivalent to kind of the semiconductor industry in the kind of 70s, 80s, where it's just basically whoever has the best technology will win. The most important thing is just being obsessed with your customer. It's very easy to get caught up in fundraising and news and awards and stuff like that. I think in general, the best companies tend to kind of avoid those kinds of things. They don't kind of aim for awards. They just aim for delighting customers. The reality of my job day to day is I still spend a lot of my time writing code. People talk about hiring. The reality of hiring is I'm just sending cold emails to people one by one. The reality of getting customers is not kind of great sales campaigns and stuff until you're kind of a major company. It's finding companies that you think will like your product and will use your product and writing a well-crafted cold email to them, spending half an hour on it. Although it's not glamorous, it's the reality of it. All you have to do is the nuts and bolts of the company, because all the company is just a team of people building a product that people use, and everything else is pretty much a distraction.
I suppose touching on to the point of, obviously this is a science technology exhibition. In your own words or in your own views, what's the next big thing? What are some of the major trends that may potentially be filling up the young scientist projects in years to come, in 5 or 6 years' time?
So from my perspective, as with Evervault being kind of an internet company, I kind of alluded to it earlier on. Although kind of growth rates are slowing ever so slightly, I think there's still a lot of work to be done there. In academia, for example, at least in our field, this is a very specific example, but fully homomorphic encryption, where you can basically encrypt data and process it without ever seeing it. That's definitely a kind of up and coming field that I think a lot of companies need to do more work on. There's a lot of work happening in academia, but it's not happening in industry. And I think to give kind of the people who are watching this like a general framework to think about this in, particularly coming from a science lens, one of the things that I find very interesting is kind of feedback cycles between academia and sort of industry, and kind of just measuring the time that it takes in different fields. So if you look at machine learning or artificial intelligence, if a paper is published with a new cutting edge machine learning model in, say, January, by March, there's already production deployments of that new model, and it's just extremely quick. Whereas in our space, in cryptography and encryption, the sort of cycles between new papers in academia and production use cases are like almost 20, 25 years. And admittedly, it's a different field, because there's, security verifications that have to happen and stuff like that. But there's a lot of fields where there's cutting edge in research happening in academia and not really much in industry. So to avoid rambling for too long, I would just say in general, look at the cutting edge fields in academia and see how long it takes for companies and researchers to build production deployments of those things, and then figure out how to make those feedback cycles quicker and try to get to a point where it's like machine learning in only a couple of months or even faster.
Looking into that crystal ball, so Shane, I think as best you can, or as much as you can tell us into that 7-year time horizon, what does 2021 onwards look like for Evervault?
So I think it's very easy for us to kind of talk about a 10-year time horizon. We're basically building the encryption engine for the internet, and our mission is to encrypt the web. So it's a very straightforward kind of goal to get to. We basically want data to never exist unencrypted, and we think we are building the best way of encrypting data on the internet. So getting companies of all sizes, initially small companies that are kind of building their first products because they're more likely to try a new technology or a new company like Evervault, but eventually kind of growing and working with more established companies, all the way up to the S&P 500 or Fortune 100 or whatever kind of metric you want to use to kind of identify big companies. We want to get to a point where that all flows through Evervault. And I think for us right now, optimizing for that is the most important thing. And it's very clear to us then, what the plan looks like over kind of a 6 month, 12-month time horizon. We're going to continue to hire the best people in the world to work on the technology. We're going to onboard new customers and make sure they're having a great experience and not just kind of having a lot of people that kind of like the product itself. We're far more interested in just delighting 10 people than making 1,000 people kind of happy. Which I think is true for most companies.
So listen, Shane, it's been an absolute pleasure. Really do appreciate your time, and best luck with everything going forward.
Cheers. Likewise. Thanks, Jack.